Here we're being asked to calculate the volume of the objects, and volume typically is easier to calculate because again, if we find an area whose slices are the same, gives the same area, then we can use area times thickness to work out the volume. So in this case here, this prism, triangular prism, I can slice it so that each slice has an area of that triangle. So when I calculate the volume then, I'm going to take my area, what we call a cross-sectional area, and multiply by the thickness. In this case, this 10 centimeters here represents the thickness. So it's going to be the thickness. So working out the area then, the area is going to be the triangle. So the area of the triangle is going to be 1/2 the base times the height. Okay, again, we have to make sure we use 90-degree measurements. So the 6 and the 8 represent 90-degree measurements. And then the thickness of this is going to be 10 centimeters. So working this out, we end up with 8 times 6 divided by 2. That's going to be 24 centimeters squared times a thickness of 10 centimeters. That gives me a volume of 240 centimeters cubed as the volume of that object. And again, volume tends to be easier because there's less to keep track of. Surface area tends to be harder that way. Looking at this object, we can break this down into different chunks if we like. So we can maybe do like a triangular prism, a rectangular prism, and another rectangular prism here. Okay. Now that can be done. So if you want to organize it that way, you can. What I'm going to do is I'm going to take the areas of these different pieces and find the total area of this object, because every slice will have that area, and then I can just use the thickness of 120 millimeters to give volume. So that's what I'm going to do in this case here. So I'm going to find the area of the different pieces of this. So again, make note that the difficulty of this problem is not the individual calculations, but just keeping track of it all. So I'm going to find the area of this triangle. That triangle has a width of 30, okay, because it's 30 this way, and 60 all the way to that edge, and it's going to have a total height of 90. Okay, so 30 times 90 is going to give me 2,700 millimeters squared of area. Okay, so that's going to be that part there. I'm just going to erase this here. This rectangular piece here, that piece is going to have a width of 30 and a height of 90. Oops, so I just made a mistake here. It's not going to be 2,700. It's going to be 30 times 90 divided by 2. So that gives me 1,350. This one here is going to be 30 by 90, so it's going to be, this one will be 2,700 millimeters squared. And then this rectangular area here is going to have a width of 100, a height of 50, so that's going to be 5,000 millimeters squared. So the area that I've calculated here, when I add that all up, is going to be, that's going to be 4,050 plus 5,000, so 9,050 millimeters squared. So that's going to be the area of the surface of that face. Now to find volume again, volume can be calculated by area, cross-sectional area, times the thickness. In this case, the thickness is 120 millimeters. Okay, so then I get 9,050 millimeters squared times the thickness of 120 millimeters. Okay, when I work this out on my calculator, I'm going to get 9050 times 120. That's going to give me a fairly large number, 1,086,000. So I get 1,086,000, and that's millimeters cubed.